Hello and welcome to the introduction to computer-based physical modeling. So this course shall introduce you into the Python programming language. And the Python programming language is particularly useful because it's easy to learn and plays nowadays an overwhelming role in scientific and engineering tasks. For example, in our lab, Python programming is almost exclusively used to analyze experimental data, to plot experimental data, and to prepare these graphs for manuscripts, for theses, and other publications. We also use it quite heavily to solve scientific problems which we cannot solve analytically. So we use Python to solve numerically problems in physics. Another thing is also very important, and that is the fact that Python is freely available and has been, due to its modular structure, extended in nearly infinite number of different ways. So you can have a module for almost any kind of purpose in Python. So this course is really intended to introduce you into Python more on a beginner level, but I hope also the more advanced users will find it interesting at some point to join us and to solve some of the problems. What we are going to use heavily is the Jupyter Notebook environment, which is the basis of this website, and also all of the notebooks which you can download and work on during the course. So you see here on the left side already part of the structure. So at the beginning I will introduce you into these Jupyter notebooks, and then we'll start with studying Python in its basis. So we'll look at variables, data types, arrays, plotting, loops, how to define functions, and all of these basic things. And then we'll come to more applied stuff, and we'll show you how to analyze data by curve fitting, how you can read and write from files, how to solve physical problems from fields like mechanics, electrostatics, waves, quantum mechanics, optics, with the help of Python. So in each of the individual lectures there will be somehow some physical problem which we are going to show you how to tackle that. And that since we have an online course this year, there's no limit in time, so we can actually extend that to almost infinite time. So we have some kind of highlight at the end of the course of approximately 2 additional lectures where we tell you a bit about machine learning and the basics of that which we are going to use. So this website is really the basis for you, your home. You will find everything, even so it's not complete yet. It will become more complete. So you see here an overview of the website in general. You also find some links, like for example that link here to our forum, where you are invited to discuss problems you have during the lectures, the exercises, or if you have questions concerning the exam or Python in general, you find some information here. But you also find information on the individual websites that we use. For example, we have heavy use of the MyBinder website. Whenever you see on the top of your web page this kind of icon, you can click on that, and Jupyter Notebook will open, and you can type in code there, and I will explain how that works. That nice website is hosted by GitHub and GitHub Pages, so this also plays a very important role for us. And finally, if you want to work at home on your Jupyter notebooks and you have no internet connection, you can download the Anaconda Jupyter package here at that website, and it helps you to explore what you've learned during the lectures or exercises. So everything will be organized that every week on Tuesdays you will find a new lecture with a new lecture video telling and explaining you all the details. Starting on Wednesday, that must be the 8th, you will also get some assignments. That means you get a Jupyter notebook where you have to fill in some codes and some answers, and that you return to me, and that will be graded, and you will get some information and some feedback on how you what you achieved. At the end of the course there will be an exam, and the exam means that you write a Jupyter Notebook yourself on a specific topic you have chosen, and that Jupyter Notebook has to fulfill some requirements. So we want you to dive into the problem and describe for us in an introduction what are the basis of these problems. Then you tackle that problem with your code and describe the results, and especially discuss that so that you create relations to other fields you might know, and in a summary you describe your major findings of that. So that all should go into a Jupyter Notebook which you submit at the end of the course, and that will be graded at the end. So there are also some additional resources here which you can find and find useful. I will also update that. You can go to my group's website. You can use the computer-based physical modeling website at our group website, where you might find additional information. And there is also the discussion forum which you can reach. If you click on that here, a new website will open where you have to log in with your computer-based physical modeling username and the password, and at the end you will reach a forum which exactly looks like that. I just forgot the password now. Which exactly looks like that as here described on the top, so you can really type in your questions at the different categories. There are also a lot of resources around on the web on Python, Matplotlib, Pandas and other things. Similarly also introductory tutorials on different aspects contained in our lecture. So you're feel free to look at those as additional materials. So at the end, you can also reach me by email. Here's my contact data. Once you have any kind of question, please ask me. So to show you how the lectures are very much organized, here are some examples. So this is the introduction to Jupyter Notebooks. If you don't know about Jupyter Notebooks, I highly recommend that you look at that. So in the overview, you see always the contents of this particular lecture and a video which explains all the details, which are also contained here in the outline of that particular lecture. Here you find the time codes if you want to skip some of the parts, and so here you have my beautiful voice in addition to the images. So if you go now to one of those outline sections, you see here on the top again the link to the Binder website where you can download and work on the individual notebook. So this is for the introduction into Jupyter, and here's the connected first lecture. And you see also this first lecture, which takes about 50 minutes overall, has a video and individual subsections which you can directly address without watching the video. You can play around with these notebooks. You can't destroy them, they are yours at the end of the day. So at the end of the first lecture there will be an exercise. There is no exercise yet because it still has to be prepared. I hope to manage to finish that until Wednesday 8th of April morning, and I can download that, type in your answers and return that to me, and the way you download that and return that to me will be published here on that exercise notebook. So this is it for a short introduction to our course. I hope you will enjoy that. Whenever you have questions, please feel free to add them to the forum. I'm happy to answer anything, and I hope you enjoy this course. Thank you very much for clicking in.